We move ahead to the next module of stationary waves. In this module, what are we going to learn? Students, from the last module, we studied the different modes of vibration of a pipe which is open at both the ends. In this module, we are going to come to a conclusion about the different modes of vibration in an open pipe, and also we are going to derive some few conclusions that we can do and few general formulas that we can do on the basis of that. So let us see what was remaining. The second overtone mode, or it is also called as the third mode. Now in this third mode, the diagram is given as follows. In second overtone mode or the third mode, there is an addition of two loops in between the open pipe. You can see there are two loops which are introduced, and then there is a half loop which is there on this side and half loop which is there on the other side. So I have, can I say, overall there are two loops which are there plus two half loops which are formed. So can I say effectively there are three loops which are overall formed. I can also say that in these three loops there are three nodes and four antinodes. Let lambda 2 be the wavelength of the wave. According to the lambda 2 being the wavelength of the wave, I can say that the half loop will be lambda 2 by 4. The whole loop will be lambda 2 by 2. The next loop will again be lambda 2 by 2. The next half loop will be lambda 2 by 4. So can I say the effective length will be 1/4 plus that 1/4 will give me half. Now half is being added not one time but three times. So can I say the length will be thrice the length of the loop. So can I say L will be 3 times lambda 2 by 2. Now we need to remember this to make sure that we complete the derivation. Let us move ahead. What is given? I know that the length is 3 lambda 2 by 2. Let N2 be the frequency of the wave, lambda 2 be the wavelength of the wave. I know that capital L is equal to 3 lambda 2 divided by 2. So can I say alone lambda 2, therefore lambda 2 will be equal to 2 multiplied by capital L, the whole divided by 3. I also know that velocity of the sound in air is given by V, which is equal to N2 into lambda 2. So can I say N2 will be equal to V divided by lambda 2, and lambda 2 is actually 2L by 3. So can I say N2 will be V divided by 2L by 3. On further solving it, N2 comes out to be 3 times V by 2L, and as we all know, V by 2L is actually the fundamental frequency N. So can I say N2 will be 3 times the N, that is 3 times the fundamental frequency, which is called as the third harmonic. Also, it is called as the second overtone since it is second higher frequency than the fundamental frequency. So students, with the help of these things, we completed the overall modes of vibration. Let us see what can we conclude from this. I can say that for a pipe which is open at both the ends, the fundamental frequency N is given by V divided by 2L. Also, the first overtone will be N1, which is equal to twice N, that is 2 multiplied by V by 2L. Since it is twice N, it is also called as the second harmonic. Let us move ahead to the next concept, that is second overtone. In second overtone, N2 comes out to be equal to 3N, that is third multiple of fundamental frequency, that means 3N, that is 3V by 2L. This is also called as the third harmonic since it was the third multiple of fundamental frequency. So can I say in general formula, pth overtone, that is NP, will be equal to P plus 1 into V by 2L. That means can I say P plus 1 into N. So can I say pth overtone will actually be equal to P plus 1 harmonic. Moving ahead to write down the final conclusions for the modes of vibration of an open pipe, I know that the frequency of pth overtone will be P plus 1 into N, that is P plus 1 harmonic. I also know that the modes of vibration, in this case, that the frequencies produced are N. In this case, I have N, then there is 2N, and then there is 3N. Moving ahead to the last case, hence open pipe vibrates with all the harmonics, that is odd harmonics are also present and even harmonics are also present. So students, with the help of this module, we studied the conclusions for the vibration of pipe and open pipe rather in a mode of vibration, or with the help of this module, we actually studied the different modes of vibration of an open pipe. Thank you.